So once again, welcome back to my channel. So the main objective of this video is to give an overall idea about computational thinking, how we can implement computational thinking in schools, polytechnics, colleges, etc. So after watching this video, you will get a clear understanding about how you can implement what is the importance of computational thinking and how you can implement computational thinking in schools or colleges or universities. So this is my website, and the address of my website is technologicalcenter.info. So my main focus is to provide an awareness about industry 4.0 topics such as autonomous robots, simulation, system integration, IoT, Internet of Things, cyber security, cloud computing, additive manufacturing, augmented reality, big data, etc. So in this tab, you can see the different options such as AI, artificial intelligence, Internet of Things, renewable energy, sustainability, mechatronics and robotics, learn Arduino, computational thinking, virtual communication lab, additive manufacturing, CNC lathe, CNC milling, objective type questions, SAT examination, GRE examination, collaboration, how different organizations can collaborate with me. Then German language training based on 7 different sample papers. Then what are the jobs available in the market related to the CAD/CAM, digital manufacturing, digital construction, STEM, design technology, design thinking and innovation, etc. So my topic is computational thinking. What is basically computational thinking? So computational thinking is a problem-solving approach. So if you are facing a problem, your main focus is to solve that problem in an innovative and appropriate way. So our solution will be an innovative solution, not a normal solution, an innovative solution. So the main objective is to find an innovative and appropriate solution to a particular problem what we are facing. So computational thinking is a problem-solving approach. So there are 4 basic steps involved in a computational thinking process, such as decomposition, pattern recognition, abstraction, and algorithm. So the main objective of learning this technique is to get an understanding about the 4 steps, and the students, they have to apply these 4 steps into their problem, and they have to find an innovative and appropriate solution. That is the main vision, that is the objective of learning this skill. So what is decomposition? Okay, so decomposition means if you are say, just imagine it, right now you are facing a problem. Okay, whether that will be related to your personal life. So I'm talking like a general way, whether that problem will be a problem related to your personal life or your professional life, your academic life. Okay, let it be any. So the first step is to breaking down your big problem into smaller manageable parts. So in this figure, it is very clear that this is your big problem, and you will breaking down the problem into so in the first step you will breaking down your problem into 2 smaller problems. Again, you will divide this is smaller problem 1 and this is problem number 2, and again you will divide this problem into again 2, and again you will divide into 4. So your big problem is divided into 8 smaller manageable sections. Now what is the speciality? So you can manage your problem very easily. Okay, if you are attempting this problem, the thing is the problem itself is big, the data, the informations, everything is complicated. But now you breaking down your problem into smaller section, so that means you can manage this section very easily, very systematically, logically. Okay, so that is called a manageable. You can manage the problem systematically. So the next step is to find solutions to these 8 manageable sections, and then finally you will integrate all the solutions, you will get the solution of this particular problem. So this is the first step. If you are facing a problem, okay, if a, let's take a student is solving a problem in mathematics, they can apply this technique to that particular problem. Okay, there is one problem. Okay, there are so many informations in that particular problem, that the first step is to breaking down the problem into smaller manageable sections. Okay, then after that, pattern recognition. When you divide the problem into smaller sections, you can understand that. So this first I will explain this image, this figure first, then you will easily understand. Here, these are your problems, right? So when you breaking down your problem into smaller sections, and you can understand that there are so many informations available, so many data available. Okay, so so if you can recognize the patterns, suppose one section is having one particular pattern or one particular trend. Okay, the one section is following one particular trend. If you are able to identify that particular trend or that particular similarity, then you can apply a particular strategy to that particular section. For example, in this image you can see I have separated my problem into 3 different sections, so that the first section is following a particular trend or a particular similarity, whereas this second section is following another similarity, and the final section is following another similarity. So what is the advantage of identifying the patterns or the similarities or the trends? So you can apply one particular strategy to that particular section. That is the importance of identifying the pattern. So that is the second step: identify the pattern, identify the trend, identify the similarity. Okay, that is what is called a pattern recognition. Then the third step is abstraction. What is abstraction? Abstraction means I already mentioned your problem is very big, your problem is complex. Okay, so that problem consists of 2 types of data: relevant data and irrelevant data. That means relevant informations and irrelevant informations. Our main focus is to focus on relevant informations only. If we are spending too much time behind the irrelevant informations, what will happen? You are wasting your time, you are wasting your money, you are wasting your human resource. Okay, you are wasting your energy, and what will be the final output? Nothing. So what are the, see, let's take another example of mathematics. Suppose, okay, suppose this is a problem. Okay, so that problem consists of maybe 10 datas. Okay, but actually when you look into the interior detail of the problem, you will understand that out of the 10 datas, only 3 datas are relevant to solve that particular problem. Am I correct? Okay, so the question makers, the question preparation peoples will give 10 datas to confuse you, but in actual case, out of the 10 datas, only 3 datas are relevant, only 3 datas are necessary to solve the particular problem. So identifying those relevant informations, that is what is called abstraction. Okay, so out of the 1,000 data, or out of the 100 data, you have to identify, out of the 100 available data, you have to identify what are the available informations, and what are the relevant informations, and what are the irrelevant informations. So that is what is called abstraction. And finally, algorithm or algorithmic design. Okay, what is algorithm? Algorithm means the creation of, yeah, welcome back again. So your aim is to create a set of step-by-step instructions to solve your big problem. Our ultimate aim is to get an innovative and appropriate solution. That is our ultimate aim. Our aim is to get an innovative and appropriate solution to this particular problem. So the step-by-step instructions, what is the first step? Okay, then what is the next step? What is the third step? Fourth step? So the step-by-step instruction. So you have to follow the step-by-step instructions, so that finally you will arrive into that particular solution. Okay, so these are the four basic steps involved in a computational thinking process. Okay, if you want more informations, if you want to explore more details about this computational thinking, uh, under each sections you can see there is a link. I have provided a link here. You can see under this decomposition, you can see website 01. You click this link, you will get uh, you will enter into a new website. Okay, that is this is a website of BBC. And in this you can read, you can explore more. Okay, what is decomposition? Decomposition is one of the four cornerstones of computer science. It involves breaking down a complex problem or system into smaller parts that are more manageable and easier to understand. The smaller parts can then be examined and solved or designed individually, as they are simpler to work with. So decomposition, pattern recognition, abstraction. So here you can see this is your problem. You will breaking down your problem into smaller sections, smaller manageable sections. And then finally you have to identify the patterns, similarities or trends. Then this is your problem, and you need this square only. Here, this, just imagine this is a cube, right? And this cube consists of how many faces? This cube consists of 6 faces. Out of this 6 faces, only one face is required. So this is a simple example to understand what is the concept of abstraction. What is the relevant information, or what is the relevant data? What is the relevant informations? You have to focus on the relevant informations only. And finally, the step-by-step instructions to get the solution. That is what is called algorithm. So you can, if you want more details, you can click the link. Similarly, pattern recognition also. Okay. So if you want more details about pattern recognition, so you can read this. Examples of pattern recognition in driving, medicine, mathematical formulas. Okay. Then abstraction. What is abstraction? What is the meaning of abstraction? Okay, so what are the relevant informations? Please read this. You will get more idea about abstraction. And finally, algorithm design. Algorithm design is the set step-by-step instructions to get algorithm thinking or algorithmic design. The step-by-step instructions to get the final solution. Okay, so that is what is called algorithmic design. Then the next step is how we will implement this concept in the mind of children's. Okay, so if you want to implement this in schools or universities or colleges, you should give an activity, right? And the next section is to explain how you can implement this computational thinking in schools or colleges or universities. Okay, so for that, uh, for that, I am using three different designs. Okay, so actually I am using a tool that is called Autodesk Tinkercad. It is a powerful tool. It is a cloud-based application from Autodesk. Okay, so it's a CSG approach application. CSG means constructive solid geometry. What is constructive solid geometry? Means you are designing. See, you are designing leaf pattern, this honeycomb pattern, this kiwi fruit pattern with the help of basic primitives. What are basic primitives? Basic primitives such as cube, sphere, cylinder, hemisphere. Okay, that is what is called a basic primitives. Uh, you will take those basic primitives and you will apply the Boolean operations such as addition, subtraction, intersection, union, etc., so that you will get the final 3D design. Okay, so that is what is called a constructive solid geometry or CSG approach. Constructive solid geometry or CSG approach. Okay, so from this figure it is very clear. So this Autodesk Tinkercad is actually, there are so many applications such as uh, Inventor Professional, Fusion 360. Those applications are using feature-based modeling, but this is a different concept called a CSG approach. Okay, so we are using Autodesk Tinkercad, and Autodesk Tinkercad is a CSG approach. If you want more details about a CSG approach, you can refer this constructive solid. What is constructive solid geometry? So you are applying Boolean operations such as union, difference, intersection, etc. Okay, yeah. So here the first step is to, so this is a design from nature, right? And this is leaf pattern. You can observe, you can find this pattern in your nature, right? Similarly, this honeycomb pattern, again this pattern you can observe, you can find this honeycomb structure in your nature. And again kiwi fruit, this is again from nature. So the main focus of these three activities is the students, they have to recreate these three designs in Tinkercad. That means they are connecting nature into their classroom. That is the main objective. Okay, then when they are designing these three designs from nature observation, they have to use the concept called a computational thinking. Okay, let's take this example. This is linear leaf pattern. First, they have to prepare the leaf base. Okay, there is a leaf base, then central portion, there is a midrib, and there are leaf veins. So the first step is to design the leaf base, then design the midrib, then connect the midrib and leaf base. Okay, and then prepare the leaf veins and arrange the leaf veins in a systematic way. Okay, and then group all the three designs together, you will get one leaf. Then once you prepare one leaf, then you have to duplicate, and you have to repeat, you have to duplicate the design, and you have to copy the design to x-axis with the number of copies, 1, 2, 3, 4, 5, 6 number of copies. Okay, so this is called an algorithm, the step-by-step instruction. First we have to prepare the leaf base, then we will prepare the midrib, then we will prepare the leaf veins, then we will group all the three structures together, then we will duplicate it, so that finally we will get the this design. Okay, so when they are thinking about the design preparation of the leaf, they will apply decomposition, pattern recognition, so what are the relevant data required here at pattern recognition? Here there are three designs, right? So this design is following a pattern called a linear pattern, but this one you can see this is both X and Y. This is called a gridded pattern. So these two patterns are different. You are applying one strategy for this design, whereas you are applying a different strategy for designing this. You are not applying same strategy for this leaf design and this honeycomb design. No, you are applying two separate strategies to design these two shapes, leaf and honeycomb. And finally, again, this is 360-degree radial pattern. You are applying entirely different strategy to design this kiwi fruit 360-degree radial pattern. Okay, so in this way they will understand the importance of pattern recognition, what is linear pattern, what is a gridded pattern, what is 360-degree radial pattern. Then abstraction, when you are designing this leaf, what are the relevant informations required? Okay, when you are designing honeycomb pattern, what are the relevant informations required? When you are designing the kiwi fruit pattern, what are the relevant informations required? Okay, what is algorithm? Algorithm means how you will, what is the first step? First step is to prepare the leaf base. Then we will prepare the midrib. Then we will prepare the leaf veins, like that. So they have to prepare the step-by-step instructions to get the final design. Then decomposition means you will breaking down this problem. Here, let's take this example. Okay, there are 1, 2, 3, 4, 5, 6. There are 7 leaves. So first they will breaking down the problem into smaller sections. First they will prepare one design. Then we will repeat this design to how many? 1, 2, 6, 6 designs, so that we will get the final leaf design. Okay, so in this way the students will learn the concept of computational thinking. uh, so they are recreating these three patterns in this particular tool, that is what is called Autodesk Tinkercad. And again, this Tinkercad consists of three different sections, such as Tinkercad code blocks, Tinkercad design, Tinkercad circuit. So we are using the Tinkercad code blocks. This is like a scratch. Okay, if you want more information about Tinkercad code blocks, just click the link provided. Okay, this is the block. You can see, you will get more understanding about Tinkercad code blocks. So this is your final design, and this is your code blocks, and these are the different code blocks available. For example, if you want to create a box, just click and drag it here, click the play button, you will get box here. If you want to adjust, you can adjust the value, and again click the play button, you will get the value here. Okay, and this is your design workspace, and this is your code blocks workspace, and this is your code block. Whatever blocks you require, you just click and drag it into this workplace and click the play button, you will get the final solution. Okay, that is the this one. This is the blocks panel, this is the blocks editor, and this is the 3D viewer. Okay, for example, if you want to create a box, just choose the first option, box. Okay, and here you can see what is the width, what is the length, and what is the height. Okay, you can change. If you want a cone, you can take cone. And finally, you can convert your file into different formats, such as .stl. This is for 3D printing .obj, gltf, .svg, shape. Okay, so that's all about the Tinkercad code blocks. Then next is the evaluation. This is a very important thing. If you are providing an activity, we have to evaluate the activity very systematically. Okay, so there are 4 outcomes I am evaluating. The first one is student documented progress while following the computational thinking process, decomposition, pattern recognition, abstraction, and algorithm. So they have to prepare a comprehensive report. If the report performance is in the range of advanced or mastering, they will get 4 points. If if their report is in the range of needs improvement, they will get only 1 point. So from this scoring pattern, you can understand that the maximum score is 4 multi. There are the maximum mark is 4, and there are 4 outcomes I'm evaluating. So 4 multiplied by 4, that is 16. So the maximum mark is 16 and the minimum mark is 4. It is the duty of the student to score 16 out of 16. Then student identified potential real patterns in nature to recreate in Tinkercad. Okay, so these are the first 3 designs, and these 3 designs are common to all. Why these 3 designs are common to all means this is to promote the concept of collaborative learning. Okay, they will discuss with each other, they will discuss with their friends, they will discuss with their teachers, they can discuss with their parents. Okay, so this is like a collaboration. This is to promote networking. This is to promote sharing informations. Okay, that is the second outcome. And the third outcome, student created patterns using the repeat block and the count with block. They have to use, while using the Tinkercad code blocks, they have to use repeat. Repeat means, here you can see this leaf is repeating. They have to use a repeat block, and they have to use count with block. Okay, so count with means how many counts? 1 2 3 4 5 6. Okay, so they have to use repeat block and count with block while they are using the Tinkercad code blocks for designing the 3 different patterns. They have to use 2 blocks, that is mandatory. One is repeat block and count with block. And the last one is student created one or more linear, radial or gridded patterns inspired by nature using variables, control blocks and math blocks. After preparing these 3 designs, the students, they have to prepare one more linear, one more gridded and one more radial pattern other than these 3 designs. They have to observe 3 designs, one from linear, one from gridded and one from radial, from the nature, and they have to recreate those 3 patterns in Tinkercad code blocks. So there are total 6 designs. They have to submit 6 designs at the end of this activity. And after finishing this activity, we will conduct one exhibition so that the students, they can exhibit their designs to the outside world, and they can collect feedbacks from the peoples, so that will be a great motivation to do the next activity. Okay, so I already explained yeah, learning outcomes, scoring, CSD approach, Tinkercad code blocks, then decomposition, pattern recognition, abstraction algorithm, and the 3 designs. Okay, so if you want to implement this concept in your organization, you can contact me. Okay, you can contact me through the website www.technologicalcenter.info. Okay, so we will help you to implement this computational thinking in your organization from grade if your organization is a school, then we will implement this problem solving skill from grade 5 to grade 12. And if your organization is a college or a polytechnic, we will implement this in the first year students. So this is a very useful technique, so that everybody, so this is a useful technique for everybody can apply this technique. This is a problem solving technique. This is a general, you can take this as a general problem solving technique. And the main objective of this technique, learning this technique, is to approach any problems, any complicated problems systematically and logically, and we will arrive to an innovative we will reach an innovative and appropriate solution. Thank you.